All right, we're back for day 3 of the matrices warm-up stuff. Just to kind of get you in the mood for this so that we can then move on to solving partial fractions, things like that. Today we're going to be talking about solving systems of equations using matrices. Vocabulary-wise, a system of equations can be represented, in this case, represented by a coefficient matrix and a constant matrix, and solve by using the following. It would be the inverse of A times the matrix B. And we'll talk about how that works in terms of just looking at the problem and then setting this up and doing the work. So let's look at the following. It says A of X, A times X plus B times Y equals C, and dx plus EY is equal to F. So first of all, the coefficient matrix. Well, that would be A, B, and D, E. And when we write this, we would set this up by doing the following. We would say we're going to multiply that by this thing, which this one is called the variable matrix. So we have our variable matrix, and if we think about multiplying matrices, it's the first row times the column. Well, A times X plus B times Y. That's what we have here. And D times X plus E times Y. So we're just breaking this matrix into a constant a coefficient matrix and a constant matrix. And the constants would be CF. And if we think about this one, if we go back to what we were saying, if we multiply these together, we get a 2 by 2 and we get a 2 by 1. And if I multiply them together, I get a 2 by 1 matrix, which is what this constant matrix is, right? A 2 by 1. And it's got an equal sign here. So it is saying that A times X plus B times Y is equal to C. And it's saying D times X plus E times Y is equal to F, which is right here in terms of our work. So hopefully you guys see how that sets up. Now, how would we do this? Well, in the last section, day 2, we talked about finding the inverse. And the whole point to finding the inverse, what was the reason that we were looking for the inverse? Well, here's the situation that we would have and maybe how we've got to think about this. So let's look at this problem right here. This one, they're kind of already putting this one out here, but I just want to kind of give you an idea of what we mean. So here you have 3x is equal to 9, let's say. Now, I want to solve for x. So what would I do? Well, normally we would say divide by 3, both sides. But we could also say it a different way. We could say multiply by 1/3. Multiply both sides by 1/3. And why would we do that? Well, you do that because when you multiply 1/3 by 3, you get 3 over 3, which equals 1. So by using the inverse, we create a 1. That's what we're talking about right here in a problem like this when you go to solve. Excuse me. It says solve the following matrix equations using inverses. So if this is A and this is B, these are our two matrices. If I want to get rid of this matrix on this side and just have a 1, well, I can't just get a 1 because we can't divide a matrix by another matrix. But we could use the inverse. If I were to multiply the inverse times this thing, and then we have xy, our variable, and we end up with this thing, well then if I multiply this side by the inverse of a, then I also want to multiply the other side by the inverse of a. Now, here's the thing with that. You can't write the inverse after. You have to write the inverse before. Okay, the reason being, you've got a 2 by 2, you've got a 2 by 1, and you can't say b times a to the negative 1. And you can't say that because the dimensions don't work out, right? You got a 2 by 2 for the inverse. You've got a 2 by 1 for b. That works. But if you flip it around, you've got a 2 by 1 for b. You've got a 2 by 2. The two middle terms don't add up, or they aren't the same. Therefore, you couldn't multiply it that way. So you've got to multiply a negative 1 times b. Hopefully we see that. Now, what happens over here on this, on the left-hand side? Well, when I multiply those two together, those give me the identity matrix, which we saw yesterday when we went over that work. It is the identity matrix. And so that would just mean x is equal to something and y is equal to something. The way this works out, you're going to end up with the 1, 0, 0, 1. And when you multiply that by xy, well, 1, the first row times the first column. 1 times x, 0 times y. That's just x. And then the second row by the column. That's 0x and 1y. That's going to mean that we just have 1s. That's the same as this thing we did up here. We just have a little more work to do with it. And so that's telling me then I have to multiply that inverse by whatever it is. So the first thing I got to do is put these into my calculator to find the inverses of those particular values. And then once I have that, I can then plug them in. So our inverse, and if we just do this in our calculator, our inverse matrices is going to be 1/2, 1/4, 0, and 1/2. So that's our inverse once we find that. And then we're going to multiply that by a. That's what I told you, just gives you the identity. So I got to take that of 1/2, 1/4, 0, and 1/2. And I would multiply that by the b, which is 2, 8. And then do the work to solve this out. We would end up with something that's going to say the following. Our xy is going to equal those two multiplied together, which is going to give you 3, 4. So it's telling me then that the answer to this one, 3, 4. That's basically what you're trying to accomplish here when you do this. Now, we don't necessarily write everything out or do all that. If you're going to use this a negative 1b, then that's how we would work it. So let's take a look at this next problem, and we'll try to apply what we were just talking about. First of all, it's a little different because they're not just giving you the matrices. Now you have to create your own matrices, but that shouldn't really be anything in terms of how we do that. We'll just start with this first thing right here that's saying, first one's going to say -3 for the x, there's no y, and then z is 1. And then for the second one, we're going to say -1 for the x, and 0 for the y again, and 2 for this one. And then the third one, we're going to say 2 for the x, -1 for the y, and 0 for the z, excuse me. And then we have our variable, and all that together is going to equal our constant matrix of 9, 2, and 10. So same process here. Here's A, here's B. What we want to do is put A, we want to put that into our calculator, then we want to put B into the calculator, and then go from there. I will let you do that. Press pause, finish out the problem. All right, so your answer here, -3.2, -16.4, and -0.6. Now, when you're writing these answers, a couple things to keep in mind. First of all, you need to make sure that that you get your three answers and that you write them as x, y, z. That would be the first thing. And that you write them as a point. These are a point on a graph. So you got to write them as a point. Also, you need to make sure that when you do this, you can use decimals as long as they are not repeating decimals. If they are going to repeat, then you got to convert them to fractions. But these are just whole decimals in terms of they don't go any further. So it's okay to write decimals as long as they are not repeating decimals. That's what you should be thinking. For the next part of this, vocabulary, RREF, reduced row echelon form. This is a technique to solve a system that reduces the coefficient matrix to the identity matrix to solve for the variables. Calculator steps: matrix, edit, put in your thing here for A, then quit, then matrix, math, RREF. Then matrix, names, you're going to choose A, and then enter. So what you'll see in your calculator will be something that looks like this, RREF, and then you'll see open parenthesis, and then when you choose A, it will say that. And then you close it, you hit enter, and it's going to give you an answer. So a couple things that we want to kind of talk you through here. In terms of RREF, it's going to look kind of this way. It says 2 by 2 here, but if you were solving one that looks like number 1 here, just down below, then you would have the following. You're going to have A, B, and then what we're going to be doing is augmenting the row. So we're going to say A, B, C, just like this, and then D, E, F. Now, this part right here, those are the solutions, the thing that the equation's equal to. And we are going to augment this, and we are going to make it a 2 by 3 situation. Now, for RREF, if it was a 3 by 3, well, then we would have something more along the lines of this. It would say A, B, C, and then we would use D, and then it would be E, F, G with a solution of H, and then it would be I, J, K, L. So here would be, if you had a 3 by 3, you're going to augment this to a 3 by 4. So 3 by 4 matrices. But this is only when you do RREF. So what do we mean by that? Well, first of all, it's probably easiest just to kind of see this in terms of a picture. So we're going to just do this on the thing. First of all, we got to come up with our actual A matrix, which would be 2, -7, then this little thing right here, and then -10. And we're only putting that in there to separate the variables from the constants. Then 3, 8, and 22. So here is our row, and then what we're going to do is we're going to say RREF of matrix A, and then come up with our solution. So let's take a look at that, because it will look a little different when you actually go to do this. So we just got to make sure that we understand that it will look slightly different. Let me go back here first of all. So let's take a look. We're going to go 1 to get rid of that, clear it. So we're going to go second matrix. We're going to go over to edit. I've got a 2 by 3, so 2, enter, 3, enter. Going to put all of the things in here based on what I wrote. 2, enter, -7, enter, -10, enter, 3, enter, 8, enter, 22, enter. So now I have that. Make sure you check it just to make sure. Then we're going to go to just what it said up here. We're going to go to, I'm going to get out of here first. So second mode. Then I'm going to go second and matrix over to math. And I'm looking for RREF. If you go up in your arrow, you will see REF, and then RREF is B. So we're going to hit that for it to say enter. Now it's saying all of that. I just need to put the actual name of the matrix that I want to find, which is A. And when I hit enter, here's what I'm looking at. Now, if you notice, looking at this part right here, this part right here is the identity matrix. And this is saying 1 and 0 in the corners. As long as it says that, then your answers are listed to the right of that. So your answer for this one would be 2, 2. Pretty easy. Most math people, when they're doing this, They prefer to use RREF than to the other one, just fewer steps that you have to take. When you guys take the quiz or the test, they may just specifically say you are doing RREF, or they may say you have to do it the other way. So just be prepared. You're going to have both to do. You go ahead and do this next one, and then we'll come back and talk about it. Pause the video. My this thing is locked up. 1 second. It won't. All right, let me close all of this so I can get down to that. There we go. Pause the video. All right, hopefully we came up with this answer. Augment this thing and then reduce row echelon form for A, and you get 102. Now, having said that, if you notice this one, this answer would have come out looking slightly different from the ones that you did before, because you will see now there's a 3 by 3 identity matrix, but that should be okay. Where it comes into some issues that you might have, what will the reduced row matrix look like if there's no solution? Well, if there's no solution, you're going to see something that maybe looks like this. 1, 0, 0, 0, 1, 0, and 0, 0, 0. You're going to maybe see something that looks like this, and then maybe you have an answer list that says 2, 3, 1. Now, it's giving you 3 solutions, but what's different is that this one doesn't complete the identity matrix. So if you look in that lower left corner, when you look at the lower left corner, you should be seeing that there's a situation right here that needs to be resolved. And what this is really saying, it's sort of saying 0 is equal to 1. And in this case, that is not going to happen, so this becomes a no solution when you see something like this where that last number is different. Now, if you are looking at it from the point of view of one that is an infinitely many, well, now you have 1, 0, 0, and we'll say 2 again, and then 0, 1, 0, and we'll say 3, and then it's still going to say 0, 0, 0 across the bottom. But now what you're going to see is something that looks more like this. Now these two right here, they are the same. This would be an infinitely many solutions. So hopefully that makes sense. You do want to practice with both. I think your homework is going to tell you to do both. If you have some questions, please let your teacher know when you see them next, and have a great day. Bye.